And we're live.
All right, so the question that we're trying to answer over here was, how do we get meaningful performance metrics out of Tendermint for both for our own understanding and also for research purposes? And that's the first question. And then the second question was, how do we make such tests repeatable by both ourselves and by the community? The answer to the second question is obviously to automate everything, but there's limits on how far you can actually automate things right now, given that we still need to sort of play around with the automated testing infrastructure to figure out for each of our own purposes how to go about automating that even further. So what I'm going to talk about today, I want to show you all what I've been working on in the last week and a half. So a bit of a disclaimer, I am by no means a Terraform or AWS expert. I started learning them about a week and a half ago. And so if anybody has any recommendations on improving the Terraform scripts over here, I don't see Greg in the call at the moment, but if anybody else has any recommendations on the Terraform side of things, feel free. And what I'm going to do is I'm going to demonstrate first want to show you what the intended outcome is of the test automation infrastructure stuff that we've been working on, and also then I want to take you through an example. I'm going to show you a demo of how it all works. So let me start sharing my screen over here quick.
No, not yet.
How's that?
Yep.
Cool. So let's start over here. Experiment automation. So Jarko, I see that you and Greg made a couple of changes to the graphic over here, which is cool. This is the intended outcome of the experiment automation work that Jarko, Greg, myself, and Mircea have been working on. And the idea is to eventually have a single node from which to launch a set of experiments. And what we define as an experiment right now is just a simple load test. And we're going to be using the load testing tool that I've been writing for the past 2 or 3 months now, this TM load test tool. And what's going to happen is, ideally, once we kick off this experiment control node, which is going to have a dashboard and metrics monitoring system built into the node, it's going to go and interact with AWS and kick off the relevant Tendermint network and also the load testing network. That's going to interact with this Tendermint network. And then all of these are going to be feeding their metrics back to an InfluxDB database sitting on the experimental control node. And that's all going to be made visible via Grafana dashboard. And what the idea is that we want to automate this to the extent that we want to be able to say, spin up an experimental control node, but only execute experiments 0, 1, 2, and 3, for example. And each of the experiments is basically going to involve running an increasing number of nodes, Tendermint nodes, and an increasing number of load testing nodes, clients. In this case, the idea is to run the key value store on a key value store ABCI app on the Tendermint network and the key value store client for the load testing nodes to interact with that. But in future, it'll be pretty straightforward to extend that to have a different kind of ABCI app and different kinds of clients. So we can eventually envisage writing a client for Gaia or, excuse me, or for other people's own ABCI apps. So what I did in the last week and a half was some work towards this. And the idea was not to automate everything completely just yet. We've made a lot of progress, and Greg's made a lot of progress on that so far. But what I was doing was to just get some results out, to do something similar to this, was to have a rudimentary monitoring server. I know I could use SignalFX, and eventually I will. But for now, I basically copied and pasted the components of this Night King node. I don't know if everyone knows the background, the terminology of here.
I think there's some reference that I definitely don't know.
Yeah, Game of Thrones reference over there. So Greg thought of the naming convention of having a Night King node that that basically commands the armies of these White Walkers over here, these zombie nodes that basically just bombard the Tendermint nodes with transactions in the hope of taking down the network. So that's where the naming comes from. So coming back to what I was doing last week, I've managed to extract out a simple monitoring server over here. So it's basically just InfluxDB and Grafana. So all the metrics will be piped into InfluxDB, and you can come up with whatever dashboard you want from those metrics. And then you have to then manually go and set up a Tendermint network, but I've got a Terraform script to help you set up a multi-region Tendermint network. Right now I've got the AMI copied to 7 different regions in AWS. And so you can spin up a multi-region Tendermint network, and then there's some Ansible scripts to be able to deploy your own configuration to this Tendermint network. I'll show you how that works as well. In the interim, while we're still in the process of creating an AMI for the TM load test tool. In the interim, what I've been doing is I just created an AMI for TMBench. So we can start seeing some results and playing around with the kinds of dashboards that we want on this side from the experimental control mode. So it's twofold over here. The experiment automation stuff that we're doing we're calling it, I think it's Game of Tendermint. We are effectively going to sort of lock down the configuration there to a large extent. It's going to be a very opinionated, automated experimentation framework. And the other set of scripts that I've been working on is something a little bit more generic so that we can play around with it internally for now until this more solidified infrastructure is up and running. And I'm hoping that we'll be able to evolve that set of scripts towards something that we can eventually repeatedly execute. Say, for example, every time before we release a new version of Tendermint, we want to be able to run these tests and get meaningful information from these tests. But I don't know, we have some idea as to what that looks like, but we need like precise, a very, very precise idea eventually as to what we're looking for. Like, how do we know if a new release is actually better than a previous release, or has it gotten worse somehow? And it's pretty complex to try and get that information in an automated way. So towards automating that, let me take you through some of the testnet stuff that I've been doing. Let me actually open up the interchain and the testnets repo. So under interchain.io/testnets, you'll see I've got three testnets set up over here, and I've got a full guide on how to set each of them up. My AWS credentials, everything are already configured on my side, so I'm just grabbing it from here for now. What I'm going to do is I'm going to set up a monitoring server. By the way, stop me if anyone has any questions. Is everyone okay to go through with the demo?
Yeah, just from this point, you have nothing. You have no infra, and you're setting up from scratch, or you already have Testnet?
Nothing. Well, all I've got is my AWS credentials, and what I've also done is just ignore these instances. These are unrelated.
Yeah.
But I've got my key pair set up over here. So this is one thing that you have to do in AWS before you kick off this process, to set up your key pair. What I'd recommend, because if you create a key pair here, it ends up being specific to this region. So it basically does an SSH key gen, but only in this region. And you can't copy that key across the regions, as far as I can tell. There's no easy way to do that. So I just used SSH key gen locally and then imported my key pair into each of the regions. Right. But you have to import it into each of the regions. So you'll see I've got each of the regions up over here. And so then what I also wanted to show you was, if we go through to the AMIs, these AMIs have been built from the interchain.io images repo, which is interchain images. It's actually come from a pull request that I've been working on recently for this. But the idea is that we have the monitoring server. Right now, the monitoring server AMI is only located in the US East 1 region. the TMBench images are only also in US East 1, but then the Tendermint images are across these 7 regions. And the specific regions are outlined in the actual testnet folder. So if we go to Tendermint over here, you can actually see which regions you can execute your Tendermint network in. So let's go and set up a monitoring server. Let me do this. So first thing with Terraform, you'll generally have to run Terraform init. It makes sure that it pulls in the AWS provider. It knows how to interact with Amazon Web Services. And I'm going to say Terraform. First, I'm going to do Terraform plan. I didn't outline this in the documentation, but Terraform allows you to see what kind of changes you're going to be applying before you apply them. Then we're going to say InfluxDB password, some password. We're going to say I'm just moving the Zoom window out of the way. And then my key pair name. So now what it's going to do, it should go through to AWS. It should check what is the current state in AWS, which is effectively nothing. I don't have anything set up over here. And then it's going to, but I have to actually set the group. Let's do this. So what I've done is I've added a variable in here so you can sort of group your deployments. So if you wanted to do multiple deployments, say 2 or 3 different Tendermint test networks, then you can add a group variable here and it basically attaches a tag to the Amazon images, and it allows you to group like the security configuration, the Tendermint nodes, the monitoring server, and also the TMBench nodes. It allows you to group them all. Makes for easier querying. Okay, then, so what this is saying over here is that it's probably going to go and try and destroy some of the existing monitoring stuff that I have. So I'm just going to remove this Terraform state over here. I'm going to run that again. So what Terraform does is it seems as though when you execute, there we go, that's perfect. When you execute a Terraform apply, it'll go and store the current state of what's been applied in your local directory from which you applied it. And then what it'll do is it does a diff between what it knows it previously applied and what's currently there. And it tries to get it to the state that you're trying to apply it to from where it knows itself to be. Does that make sense? So that seems okay. So what it's going to do over here now, if we run through what it's going to create, it's going to create one AWS instance, the monitoring server, and it's going to create a security group for it. Basically allows us network access to this particular monitoring server. And we're going to go ahead now and we're going to apply this. And once it's finished applying, so I'll switch over to, oh yeah, wait, I have to tell it yes. So I'll switch over to my instances list over here in AWS. And now you see the monitoring server is now being created. The security group's been created and the monitoring server is coming up. Now this just runs InfluxDB and Grafana. Now what you'll see is there are a couple of output variables from Terraform. So basically at the end it spits out how to access the Grafana dashboard. Right now I don't have TLS, I don't have HTTPS enabled yet on the Grafana dashboards, but with Let's Encrypt or self-signed certs, I should be able to do that pretty quickly. And it also gives you the URL for InfluxDB on the server. So now this is pretty important because when you set up your Tendermint network, the Tendermint testnet infrastructure doesn't know about where the InfluxDB URL is. This allows you to have your own InfluxDB server or use whatever other monitoring service that supports InfluxDB to be able to pipe your metrics from your Tendermint network into that foreign database. So what I'm going to do is I'm going to grab this URL, and I'm going to try and open up the Grafana dashboard over here. So there we go. You see we have a nice shiny new Grafana dashboard. Default username password is admin, and then we'll change the password to make it simple. And now we've got an empty dashboard with nothing in it. Now, with the experiment automation framework that we're going to come up with, that we're in the process of building, we're going to have predefined dashboards. But as to what goes onto those predefined dashboards, that we're going to need feedback from the rest of the team. Obviously, we want to be able to see things like number of transactions per block, and we want to see, maybe we want to see CPU usage and memory, like RAM usage. But as to which metrics are the defaults that we build into this experiment control node, that we're going to need feedback from the team for. So what I'll do in the interim, I'm going to go and explore, and you'll see there's nothing in here yet. From this explore panel, you can actually go and select measurements that have been submitted. And is everyone somewhat familiar with InfluxDB? Is anyone not familiar with InfluxDB?
I am not.
Yeah.
Okay, so InfluxDB is basically a time series database, and it stores, I think the terminology is measurement for the SQL equivalent of a table. So you'll have a measurement like Tendermint, number of transactions per block, and that'll be a metric. And then you'll have CPU usage, that'll be another metric. But then within a particular metric, you can have subfields. So I'll give examples of what that means shortly. So what we'll do next is I'm actually going to open up a separate terminal for this. And I'm going to go to the, let's spin up the Tendermint network now. So there's two aspects to spinning up the Tendermint network. There's the Terraform aspect, which is making sure that all your nodes are deployed in AWS. And then there's the Ansible aspect, which is taking your Tendermint configuration that you've created using, so for example, Tendermint Testnet, and then copying that across to all of your AWS nodes. So what we'll do first is we'll go to Terraform. I'm going to make sure that my AWS codes are set up locally. Actually, I'm going to remove the Terraform existing state over here. I'm going to say Terraform init. So I've got the AWS provider. And now, this is the more complex one. So I'm going to go back to my Tendermint Terraform script. And you'll see in the Terraform script, you define variables that you pass into Terraform to control different things. So I specified a number of variables over here. Like you can specify what size of AWS instance you want, or what's the volume size of the Tendermint node, the root file system size, how many gigabytes big do you want the file system to be. And then you've obviously got to point the Tendermint. So there's a Telegraph instance that runs on these Tendermint nodes that basically it polls the local Tendermint nodes Prometheus endpoint, and then it pipes those metrics through to your InfluxDB server.
What's Telegraph?
Telegraph is a daemon that runs, it works along with, it's from the same people that created InfluxDB. Influx Data, I think, is the company name. And then it basically,
so it's like an InfluxDB client?
Yeah, you can think of it like an InfluxDB client. So it can poll a number of different input sources. So from Prometheus through to whatever it is, it can get system metrics like CPU usage and networking and all of that. And it can even get metrics for like SQL databases or whatever other kinds of inputs they have support for or plugins for. And then it collects all those metrics and then ships them off to like InfluxDB. So some of the other variables that I've got in here that are specific to the Tendermint network are the number of nodes that you want to kick off in each of the regions. I don't know if there's a more elegant way of doing this, but this is the easiest way that I could think of so far. So let's kick off a Tendermint network here. So we're going to say Terraform plan. And now we have to actually specify the InfluxDB URL. Just going to copy paste it from here. I want to use the same password. Just want to make sure. And the group is demo. We're going to go for small instances. The telegraph collection interval is pretty important because, as you know, Prometheus, you don't get a continuous stream of data out of Prometheus. In order to get the metrics from the Prometheus endpoint on the Tendermint node, you have to poll it. And so the more frequently you, there's a bit of a trade-off there. The more frequently you poll it, the more high resolution information you can get. Whereas the more frequently you poll it, you may also increase the load on the Tendermint server itself. So I think polling, perhaps, I haven't tried polling every second. I've tried polling every 3 seconds, and that doesn't seem to have any impact. The Prometheus endpoint seems to be pretty lightweight, but it depends on the metrics that we're exposing. So the more metrics we expose from Tendermint, the slower it becomes to extract all that information out of the Prometheus endpoint. And so then we kind of have to find a bit of a sweet spot over there as to how frequently to poll it. I'm pretty sure we could right now even poll it every second if we wanted to, but we may miss some metrics in the process, or actually I'm not going to change it there. Let's do it from the command line. And I'm going to say I want to collect metrics every 3 seconds.
So Tin, I have a question here regarding what you just said. If you're interested in some sort of like aggregate statistics, like average or median, this seems like that it depends on the frequency of polling. So if I, for example, if I poll every second, and I don't know, the last number of transactions in the last block hasn't changed, then we'll sort of, if I understand well, we'll have the same value appear, I don't know, 5 times, although we should kind of count it only once.
No, sorry?
If you want kind of to average this, although maybe averaging here is in terms of time and not like in terms of the number of instances. So it's in general kind of hard to do.
Yeah, so when Telegraph polls the Prometheus endpoint, it attaches a very precise timestamp to that set of metrics. So if you're calculating an average, it's got the number of metrics, it's got the value of the metrics. You won't mess with the average, but the only risk here is that you may miss deviations. Like you may miss if you have too high a collection interval. Say you're collecting every 10 seconds, but you're generating a new block every second. You're only going to catch the number of transactions in every 10th block.
Okay.
In which case you're going to get inaccurate statistics. Maybe in the aggregate, depending on the type of traffic that you get, you might get somewhat accurate metrics. But in this case, and this comes down to, I don't know if anyone's familiar with Shannon's theorem, the information theorem, where when it comes down to sampling, so digital sampling of data, where if the frequency at which your data changes is higher than your sampling frequency, you will lose information. So in order to make sure that you get all the information in a particular signal, you have to sample at a higher frequency than the frequency at which your information changes. Does that make sense?
Yeah.
So in this case, we're going to be losing information if we sample every 3 seconds, because right now the configuration we're going to use is to create empty blocks, and to create a block every second. But I mean, we could potentially push it higher and see what that, actually, well, we might as well try. Well, let's start with the lower value first, and we can try a higher value later, faster value. So by default, And Terraform allows you to specify default values for all of these variables. By default, we'll deploy 4 Tendermint nodes in the US East 1 region. I think that's North Virginia. And if you want to change that, you've got to override these variables here. So what I'm going to do is I'm going to put 1 in US East 1, 1 in US West 1, 1 in US East 2, and 1 in Asia Pacific Northeast 2. So let's plan that. Great, so it's going to say that we have to add 8. Part of these things is the security groups. So for each AWS region, you've got to create a new security group to govern the network traffic, which ports are open and accessible to all the nodes. So you'll see that for each region, we create one of those. So we're going to be creating 4 Tendermint nodes. And because we're in 4 different regions, it's going to create 4 different security groups. So there are 8 resources that Terraform has to go and add on AWS. And you'll see now, if we go back to the AWS windows here, in this region, we've got a monitoring server up and running. And in the other regions, we don't have anything at the moment. So now, let's go and create our Tendermint nodes. So node 0 is being created in US East 1. We've got node 2 being created here. I've got a particular naming convention as to how I spin up the nodes, and that's because of the way that the Tendermint testnet command works. So you generate configuration that generates, according to the naming convention, node 0, node 1, node 2, and so on. And we kind of have to keep that way. But what'll happen is the scripts will take care of which nodes, the node numbering for each region. Okay. So there we have our 4 nodes. What I'm going to do, so you'll see now, once the script's finished running, it'll spit out a bunch of output variables. Terraform calls output variables. I'm basically just giving out the public DNS for each of these nodes. And what we'll do is, in order to SSH into these nodes, one of the easiest ways to do that is to use SSH key scan. I don't know if anyone's familiar with that. So we'll just do also does everyone remember from Greg's presentation on Ansible that you need to gather the keys of all the foreign servers to your authorized keys in your local machine. Otherwise, it basically won't let you connect. I'll show you now what I mean by that. 0, 1, 2, 3. So what I'm going to do now is I'm going to SSH into one of the nodes and check that everything's up and running. There we go. So this is node 3, and you'll see that Tendermint has failed to connect to the ABCI socket, and that's because we haven't configured it yet. I'm also outputting Tendermint logs to var log Tendermint. So we can actually go and fetch those logs after doing our testing. It's one of the shortcomings of systemd. But with rsyslog, then you can pipe your systemd logs out to a file. So that's all set up. Now we should actually start seeing some metrics coming through because Telegraph is up and running. It's connected to this InfluxDB instance over here. Now we can actually see some CPU usage and disk usage, memory, and so on coming through from the Tendermint nodes. And I've tagged the nodes such that, so now you wanted to look at node ID. We only want to see node 0, for example. And we want user CPU usage, and we want a linear line over here. This little Grafana Explorer is pretty useful for trying to figure out, before you create a dashboard, what kinds of queries you want to actually execute. So we'll zoom in over here. You can kind of see the CPU usage for node 0. We can change this to node 1, node 2, and so on. You can also remove this, and you can get the average CPU usage, the mean CPU usage across all the network nodes if you wanted to. All right, so next thing is to actually generate the testnet configuration. And I've got a bit of a description of how to do this in sequence over here in the guide. So we've already launched our VMs. Now we're just going to generate our testnet configuration. First, actually, let's set up our Ansible hosts. So if everyone's familiar with Ansible after the last presentation, basically have to tell Ansible where the hosts are. So I'm giving them aliases. By the way, this is important to call the group of nodes Tendermint over here. And our naming convention over here is pretty important too. So it has to be node 0, node 1, node 2, and node 3, and they have to correspond to the particular nodes that you've deployed over here. Eventually we'll automate all of this, but to automate that is quite a bit of work. This sort of last mile automation. Let me get rid of these existing hosts over here quick. Node 1, node 0, node 1, node 2, node 3. As you can imagine, if you had 100 nodes, this would be pretty tedious. So we're definitely going to be automating this. Then, so we're going to need this. We've already got the SSH keys set up. We need these for our testnet command. So I'm going to grab them and just do this. Make some IDE hacking. And I've got 0.31.7 over here at the moment. Let me just make sure that. So let me use the current develop branch. This goes some. I think is annoying. The idea here is that the Ansible scripts are going to help you to deploy your own local version of Tendermint. So if you want to use the latest version of Tendermint on develop, you have to make build Linux because the target machines over here are all Linux based. They're all CentOS. And you're going to point Ansible to the location of your local Tendermint version. So I've created a file over here. There are 2 parameters you have to give Ansible. You have to tell it where to get the testnet configuration, which we'll generate shortly. And you have to tell it where your Tendermint binary is that you want to deploy. Okay, so while Go is doing its thing, I'm going to generate the testnet. What we want is the config, I've got a default configuration template down here, so that'll allow you to configure things like, well, it's the base template for your Tendermint testnet, so you can configure anything, the mempool size, whatever. This one's configured to actually use, let me actually show you. This one's configured to use the key value store, ABCI app. Sync is enabled, we're using Go label DB, pretty much all standard configuration options. One thing you do have to make sure of though is that Prometheus is enabled. And I think that's pretty much it for now. Otherwise, everything else is pretty much standard. So we'll do Tendermint testnet. Use this default configuration. We want 4 validators, and we want all of our host names. So that's 0, 1, 2, and 3. Then the output, let me just make sure. Yeah, delete the existing one. Great. So now we have 4 validators configuration set up under this testnet folder, 0, 1, 2, and 3, and they're basically configured with each other's peer addresses. So they should be able to, once we deploy this configuration, they should be able to immediately come up and see each other, and they'll connect. What I'll do in the interim is I will actually log into one of the servers. Let me grab node 0. Tell the logs here. And then finally, we're ready to actually deploy. I've already got the Ansible configuration, the Ansible command over here. So what we've got to tell Ansible is which host file to use. And in our case, it's this host file with the 4 EC2 instances we've already set up. We want to import the local variables, which again tells Ansible where the Tendermint binary is and tells it where the testnet configuration is and all your node configurations. You can use whatever method you want to generate your configuration. And then you obviously have to tell it to use the EC2 user. By default on AWS, I don't know if everyone's familiar, but you can't log in as root. You have to log in as a user called EC2-user. And then you have to provide it with your private key as well as the deployment script. So this deployment script should then go and actually deploy Tendermint to these 4 nodes. Now, if all works well, then what will happen is this will be green. It goes and figures out which Python interpreter is running on the target machine and picks up stats about the target machine. So success. So it means we've successfully been able to SSH into all 4 nodes. It's now going to go start Tendermint. So you'll see here that this will no longer service Tendermint start status. Currently start. Great. Now it's in the process of syncing my local Tendermint binary across to the server, the one that I built over here. So that's current develop. I'll just wipe any of the existing data or config on the target machines, and then we copy across the testnet configuration that we generated to each of the nodes. So node 0's config, the config in the folder called node 0 will be copied to the node that you've labeled as node 0 over here in your host file. usually takes a little while because it does individual file copies and checks to make sure that, and it also does a check to see if the SHA-256 of the target file is different to what it's copying across, and sometimes it can just take a while. And just double checking permissions, make sure that our systemd service is present. And then we should see it start up here. There we go. So we have a Tendermint network up and running. Height is climbing. And shortly we should be able to go back to Grafana over here, and we should be able to pick up on, there we go. We've got all the Prometheus stats coming from the Tendermint endpoint. So now you can actually go and see, okay, a simple one. Let's check our consensus height. And what we want to do is we should take that out. Time range. Let's do, sometimes it seems as though you need an aggregator over here for it to actually show. So right now we have 4 validators. And we have probably 0 in the mempool, which is good. We have the consensus height should be climbing. There we go. You can actually see the consensus height climbing here. And I think the reason why we need an aggregator over here is because we're getting this same metric from multiple target nodes. So it doesn't know, if you take this out, if you remove that, then Grafana doesn't know what to do with it. So for now, we'll take it out, but then we've got to add a selector over here. So for a particular node ID. And I think that we may still need to, I don't know why we still need to use an aggregator over here. But that should be the same on every node. All right, so there we have a Tendermint network up and running. Now, let me keep that going in the background. Now what we can do is, for our own purposes here, we want to do a little bit of load testing. So for this, I'm going to be using this TMBench image. And I've set the TMBench image up in such a way that you can specify multiple executions of TMBench. Let me find the documentation. So say now you wanted to execute TMBench against a particular network 4 times. What you would do is it's a bit ugly at the moment, but you would use semicolons between values in specifying each of these variables. So if you want to run TMBench for 4 times, each time for 360 seconds, then you would have 360 semicolon 360 semicolon 360 and so on. So let's do a single run of this TMBench tool. Terraform init. Let's make sure we've got everything and everything's up to date. And we're going to say, in this case, I'm actually going to reuse part of this command for some of the variables. Is everybody following so far?
Trying.
Yes.
Let me know if there's anything that I need to clarify.
I mean, one thing is like it seems like there's still quite a bit of manual
Yes,
involved.
definitely.
So maybe you can speak to the plan for better automation around this, or like how these components are kind of maybe able to be used as modules, but ultimately like the user doesn't have to string them together like this, or what's the thinking?
Yeah, so to go from one to the next, especially to go from deploying a Tendermint network, let's say deploying the AWS part of the Tendermint network through to deploying its configuration. See, it's challenging to automate that, right? Because you need to know unless you're setting up a seed node, in which case then it might be a bit easier to overcome this. But in order to configure the peers to know where each other is, you need their host names. And so you can't generate the configuration until you know their host names. So you got to deploy the hosts first, and then you can actually add that to the configuration. So part of the plan, and Anka submitted an issue yesterday to Tendermint, is to augment the testnet command to be able to take a configuration file itself. So to be able to define more complex test networks with different subnetworks and validators that will come online later on and so on. But you still need to somehow supply the host names to that particular command. So we need some way of automating, and I haven't figured this out yet because, again, I only started learning Terraform like a week and a half ago. We need some way of getting the output variables from Terraform into the testnet configuration commands.
Ben, do we have to use the testnet command?
No, you don't. You can use whatever you want. It's just easier to.
So, I mean, we could automate. You could automate what you presented today. It doesn't seem impossible or hard. I mean, the same way.
No, it's just the testnet command already has a lot of the machinery to be able to generate that config. It was just it was easiest to use that. I mean, I could go write a whole custom thing that takes the outputs from Terraform and then generates config files from that. And I think that there may be a more elegant way, most likely, and somebody better versed in Terraform might be able to tell me that. I'm pretty sure that there's some kind of either a plugin or something that we could write for Terraform that would be able to take the outputs of that and then use that directly to generate configuration for Tendermint. But you still have to write a plugin. Fortunately, the plugins for Terraform are all written in Go. So
I might have a few ideas for you that doesn't really require to write an additional.
Cool.
And relying on a seed seems like, I think, kind of valid option if this simplifies a lot of setup.
Definitely.
Because it's also very close to what we have in real networks. So normally we rely also on seeds, at least to some extent, for setup. So
yeah, definitely.
Another option that I was using, but locally.
Yeah.
And I know that we already said that it was not really an option, but probably something similar could be used, is that I was deploying a Kubernetes network. So you have a kind of like another layer of networking that hides all this complexity of different AWS nodes. Maybe something based on Docker Compose or something similar could work too.
Yeah, so for deploying Docker-based stuff, the only thing that really makes sense for me is something Kubernetes-based. So Ethan and I were talking about that yesterday, and I mean, that is definitely one option. It's just, again, Kubernetes has its own massive learning curve. Even to do something rudimentary in Kubernetes, it will take us, the whole team, quite a bit of time to learn that. So we kind of have to weigh up the pros and cons of going down that rabbit hole. If we're going to do straight AWS, then, you know, Greg, if you have some suggestions as to how to get output variables from, maybe writing a plugin for Terraform is probably the better option, something like that.
Another kind of like quick way of extracting that is JQ, that allows you to query the JSON output that you got there. So you could like say, give me all the hosts.
Yeah, the trouble is that it's not just JSON output that comes out in the output. You'll see there's all this stuff as well that comes out through the output. And then it's got outputs and then...
Oh, I see. Sorry.
So it ends up
I thought it was only the JSON there at the end. I see, sorry.
And this is also HashiCorp's own configuration format. It's not really JSON as such.
Yeah, exactly.
So you have to then write like a parser for that, and you know, I haven't had time to do something like that yet. So that is definitely one thing that I considered. But also, you can use the Terraform show function to to output the current structure of what's been deployed, in which case then you can use JQ, because then you can tell it to use JSON on the output. But then you still have to automate that. Eventually you're going to end up with this, the best word I can just use to describe it is janky set of scripts to kind of hold together the scaffold of, and I'm trying to find a more elegant way of doing that, ideally. But if we have to use a bunch of bash scripts, then so be it.
Maybe the Night King can have like a DNS service or something like that.
Yeah. So once we're done with the Night King work, it's definitely going to be a lot more automated, because then the Night King node is going to go and is going to go and spin up the network itself from within AWS, and that's still in progress at the moment.
Can I mention something? I think we have the right team for this. So yes, the Night King is going to automate a whole lot of things, but right now the Night King's best case is that you give it say a GitHub repo, which contains your experiments, and then it builds everything and runs the whole thing. And that's great. But in the GitHub repo, we still have to use Terraform to describe our network. And I think Terraform in this format is still quite complex.
Cool.
What would be, can we come up with a template language? Did anyone see anything like that, that describes easily a Tendermint network? Like I have 4 nodes, 2 in this data center, 2 there. And by the way, there's a network connection issue between these 2 nodes.
Yeah, that's hard.
I know. That's why I'm asking all the team. Maybe someone has, you know, someone has worked with something similar, completely unrelated to.
So when I was working at Cisco, we did have a language, and it was actually an ASCII file. And you just say node 1. I mean, it's just a simple convention. It doesn't have to be complicated.
Mm-hmm.
That's pretty much for CLI. I mean.
Awesome. Was it internal?
Yeah, but I mean, we can look for something complicated. Just to get us started, you know. Right. Of course, maybe it won't scale. When you talk about 100 nodes, you'll need some kind of UI, backend build on the at the back. But just to start, for me, to be honest, I mean, this is amazing work, but I'm trying to figure out if it's not beyond my capabilities. I mean, it took us 30 minutes, let's say, without comments to get to this point.
Mm-hmm. Well, if you have to do it manually, it takes a lot longer.
Right. Oh, definitely. So I really like this. But I will give it a try myself. To be honest, I want to try. But for the configuration template, I think start with something very simple, or maybe we find some kind of network graph specification, because that's pretty much it. And for some tests, I personally don't even care about the region. I just want 5 nodes to be started, and that specify an image for the nodes and the config for each node. Something very simple like that.
Kind of a quick suggestion here, because I was talking to some validators on the Cosmos network, and I know Cetrus One had a Kubernetes cluster of 100 nodes running when we were still in testnet phase. So it might be beneficial to.
It might be beneficial.
You broke up there.
Yeah, that's the other question. Is it what's the you know, for whom do we build this? Is it for developers, or is it for?
Yeah, there are 2 audiences here right now. The one for the experiment automation is for us internally to start extracting some results for research papers, and also to make that code available to external people to validate our research results. Mm-hmm. So that's like the Night King nodes with the White Walkers and that game of Tendermint stuff. And then there's a separate approach that we have to kind of iterate towards for us as developers. And we could, as us as developers, use the experiment automation stuff, game of Tendermint stuff. But it also depends on how you want to execute your experiment, because Anka, like your experiments are pretty complex. And I don't know if we can cater for the automation of those kinds of experiments in the Night King nodes configuration, for example. And you may think of additional things that you want to try to experiment with, manually play around with. It might end up being quite complex. So for us as developers, maybe we do have to start looking at Kubernetes, and because there it's pretty straightforward to automate all this stuff. But I'm not sure.
How we look at the Terraform examples for Kubernetes? Because seriously, I don't know Kubernetes, but I could manage to get a testnet like running locally very easily.
Yeah, if you have Docker images, then it's a lot easier as well, right?
Yeah, exactly. So it's just deploy Docker, and
you
build a Docker for your local code, which we already have that. We just say build Linux and the local testnet, instead of like sending that locally, you just like push it with Terraform.
Yeah, and then I'm assuming it pushes the image to the relevant regions, and then you can just spin up the network on Kubernetes in the remote regions, right?
I just have one comment here. So I have a feeling that with this experimental evaluation framework, we need to go also step by step.
Yeah.
Like we can't do this in one go. It's very complex, and I think that also what is very useful from this kind of intermediary presentation is for people to understand how complex is this thing. So I think that probably without adding more complexity on top, we should probably finish this iteration, try to sort of use it, and then figure out how we want to iterate on top of this. I think there is still a good hope that with I think what is planned as a Game of Tendermint project to automate this intermediary step, and that we still have almost automated the whole process, which would be kind of completely amazing. And I don't think, if I'm not wrong, Tane, like a lot of stuff you were doing today will be sort of automated at the end of the of game. Yeah. So
this is all I've been able to come up with in about a week now. So
yeah. So I think that like for example, with maybe some shortcut like using a seed node and then maybe simplifying a bit what you can configure, we can have something relatively simple, almost fully automated. And then we can maybe iterate from there and figure out what works for us, what doesn't work. But somehow I have a fear that if we start adding a new tools on top of this, that it will be never-ending story. And so like it would be very hard to have something sort of done so we can start using it.
Yeah. So,
because there is a really fundamental complexity here. It's like there is inherent complexity on setting up this thing in this cross-regional sense. So it's not like it will not go away. We just need to build a good abstraction on top of it, so we can manage this complexity. But it will not. It will just not. It's not that this is like a bad design and we have complexity there. So
yeah, I mean it's very difficult setting up distributed networks in general. I mean, like to artificially construct a somewhat realistic test network that behaves in particular ways, in different kinds of ways, like that's very open-ended. I mean, what do we mean by a test net that behaves in different kinds of ways? Like in Anka's situation where you have a bunch of validators that will come up, you submit a bunch of transactions, but now then another validator needs to join, and then you need to watch. You want to be able to see what the interaction is like when the fast sync kicks in, for example. And so like what are all the different modes in which we want to test the software? We have some idea as to all the different modes, but
I agree with both you and Žarko actually, and I agree it's difficult, but I think it's essential.
Yeah.
If we don't have this, I mean, testing locally with 2 or 4 instances, not being able to inject faulty images, simulate all kind of failures, it's going to, I mean, we are at the mercy of the clients who are running validators to submit reports and do the testing.
Yeah, definitely.
And I understand it's going to take a long time, but you know, I look at this, you've done all this in a week or 2 weeks. For me, it's absolutely amazing. So
cool.
I think we're on the right path. And, you know, if for my scenarios, which I think should be everybody's scenarios, because validators come online whenever they want and start syncing, and then they have to be part of consensus later, maybe. That one, you know, as an intermediate step, I can live with maybe starting a 7-node network, and then kill one of the nodes, and then restart it later or something like that, right? I mean, there are workarounds once this is a bit easier to just basic network bring up.
Yeah, I think that what we are trying to achieve here is this reproducibility, and I would add also this kind of requirement of social aspect to it, or coordinated work, because very frequently you do some experiments and then you ask someone for a help, but then, you know, experiment is over, it's not easy to reproduce, it's kind of extension of it works on my machine, so it works on my experiment setup.
Yeah.
And this is super hard, and so what we are trying to kind of achieve here is really this reproducibility, that the experiment is captured well enough that it's clear when someone come after, you show experiments to someone, he understand what was the setup, what was the kind of network setup, configuration parameters, what was the application running on top, how long, you know, how experiments look like, for how long, how many clients, etc. And so you can kind of read this thing and then go to the relevant dashboards or maybe log files, and then try to discuss about this. And I think this is kind of, it's not easy goal to achieve. And I think what you are mentioning with these kind of network setup specification tools is definitely, it would be super cool to have. It would really be helping with this. But just, I'm just afraid that we are kind of trying to solve too many problems at once. And although like Tane and Greg are like amazing, that even for them it takes some time to really master this thing and to really have it in a form we can use it. So
yeah, so cool. I think that there's definitely some ways in which we can. Sorry.
Sorry. I just want to make sure we still run the TMBench.
Cool. Yeah, I want to show you the TMBench thing. I just wanted to say, I just realized now one of the ways in which we can automate the step of doing the Terraform scripts to the Ansible deployment is to use the approach that Greg was talking about with Ansible, where you use an EC2 Python script. But again, like you see, also like Jacques was saying and like Uncle was saying, one of the things I did want to illustrate over here is the level of complexity involved in going through this deployment process. And this isn't even manually. Like if you did this manually, clicking AWS web GUIs and all that would take forever. And manually SSHing stuff. So what I'm going to do now is I'm going to kick off just a single TMBench instance. It's going to run a single experiment for a minute, single load for a minute. It's going to use the broadcast TX async, and I'm only going to send 100 transactions per second, and then we'll see what comes through on the graph. What's also cool about this image is the moment that it finishes executing TMBench, it shuts down the machine and automatically destroys the machine. So you don't end up paying for unnecessary resources. So now what we'll do is we're spinning up the TMBench image also in US East 1, and I'm pointing it towards only a single node in US East, the single Tendermint node in US East 1. So it's basically going to send a bunch of transactions to this node, and then those will propagate across to the rest of the network. So here we have a live graph that I've set up on the dashboard of the transactions coming through. So far we have none. And then once this is up and running, then we should start seeing some transactions come through. In the meantime, I set up the number of transactions per block and the size of the mempool at the time. Check what's happening with this node. I didn't set it up correctly. That's why. Needs the port. That's the nice thing about Terraform is that if you want to make changes to what you're running, it'll go and destroy the relevant resources and then recreate them. The new parameters. Yeah, I can imagine that running this kind of thing on Kubernetes would require less scripting, but more learning, if that makes sense. Like it would probably take a lot of time mentally to get into that.
Yeah. Also, I'm just wondering. I don't know about Kubernetes, so maybe I'm saying something which doesn't make sense. But like part of the goal is really having control over this kind of networking setup. So so we don't want to sort of get rid of that part. We just want to manage that complexity. Because once we have more complex setups, we would really want to say, okay, this guy is connected to that set of peers, and this guy is connected to that set of peers. So we can test some, P2P or ghosty functionality. So I don't know, like whether
that would not be effective. I mean, basically, you're building bridges in Kubernetes, but still, what I didn't see Thane using is AWS VPC, where you can use like your own subset of addresses. So you create a virtual private network.
Yeah, so there is a VPC setup, and then I've created a security group for each of the deployments, each of the groups.
But I understand in that case you could assign something like, I don't know, 192, 168, blah, 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 to each of your networks, and then you can like hard code the IPs, and then you don't have this kind of uncertainty of like public IPs. Yeah,
so then you're effectively creating a private network across multiple regions, right?
Correct.
Yeah, so you can definitely do that. That's definitely one way of mitigating this. Again, I only started learning AWS about a week and a half ago, so like there's definitely a potential option. But then, what's the
other option is you it could be more expensive, but you can pay your own DNS and handle your own DNS service.
Yeah, so you can handle your own DNS too.
Stuff, right?
Or you could just set up a seed node, right?
Yeah, of course. But if you want the full complexity and like reality, like having a dynamic DNS or something like that would solve that problem.
Yeah, definitely.
You just put that in the image that you are deploying.
So Kubernetes will essentially give us possibility to have kind of logical names. So we don't kind of...
Yeah.
Oh, what I was just saying was pure AWS, no Kubernetes.
Yeah.
But like with the Kubernetes, when we talk about Kubernetes, like what would be the...
So like, Kubernetes is a network of Docker containers, basically. That's what it is. I mean, later it has like more stuff like automatic scaling and stuff like that, but nothing that we will actually use. But
yeah, so in our case, like what would be the benefit of Kubernetes? Like with respect to complexity we saw, like where you see that it could help us?
Well, in my case, basically I built a Docker image, and with Terraform, you deploy the Docker image to some host, and that's what you do. So there is no Ansible. And
yeah, so the assumption is that you have a Kubernetes network running, right? So you've got a Kubernetes master, and you've got all the Kubernetes worker nodes basically, and everything is all set up for you. So you use some managed service like, Juan, did you use a managed service like what's it, EKS?
Yeah, like
EKS?
DigitalOcean provides a managed service for you.
Cool.
You don't even need to set up the stuff. You just say deploy this Docker image in that node. But if you want to reduce the complexity, maybe like having a dynamic DNS or using VPC, as we were saying, with like kind of private addresses would work too, right?
Definitely. No, it would definitely help. I think that...
is that my take? Of course, I have not played with this, but I have to set up my local network to play with the KMS, and I went through kind of similar pains.
Yeah. I think one of the things that's glaringly apparent is that when testing distributed systems like Tendermint, specifically Tendermint, there's no escaping networking complexity on one level or another, whether it's AWS, whether it's local networking, whether it's Compose, whether it's Kubernetes, whatever it might be. There's some complexity involved, the inescapable complexity on the networking side that we have to unfortunately deal with, but it's kind of like, pick your poison.
But I'm also concerned about like Sarko's requirement about reproducibility. I mean, these systems can get like very chaotic. So even if you are unlucky and it's the same zone, but it's slightly different, you end up with like completely different results.
Maybe. But I mean, like that's also a meaningful result, right? So everything else considered, if the experimental setup is exactly the same between two people's machines and they get different results, then at least you can say like, okay, well, here I saw that the peer went down because AWS connectivity between these two regions went down. So that's also meaningful. But the idea is to make sure that like we don't go and use like our own custom built set of scripts to do a bunch of testing, and then someone who wants to validate our results, they go do a bunch of tests on some other Kubernetes network, and then somebody else still goes and does it on the DigitalOcean network with a completely different set of scripts. They just manually spin up like a bunch of nodes and use Ansible to do that. So we want to provide like a kind of standardized tool set to be able to say, what we ran for our experiments, you can take it exactly, just add your credit card details there for AWS, you run it and see what you get. To what extent can you validate our results?
No, I completely. I agree that Kubernetes might not be kind of the best tool for reproducibility. So I would not. Personally, I would not use it. Correct, but I'm with Anka more like from the user perspective with Anka, and yeah, it looks like a bit too complex. Still.
Yeah, it's very complex. Trust me, it's very complex. It's and we're definitely working towards making it simpler. But so I just wanted to let you all know that the simple little load test that I ran over here for a minute, it's finished. So you can see it submitted a bunch of transactions, and you can check out the mempool size and the number of transactions per block over here. And you can set up whatever other dashboards and things you want. Once I do the SignalFX integration, then you can just actually use SignalFX, and then you can log in there and use whatever other predefined dashboards you have to see what's going on in your nodes. Is there any questions about the Grafana stuff? Does anybody want to see anything else in particular?
So, Thane, I have a question. Maybe you mentioned, but I didn't catch. Can we pull the logs easily? How do we pull the logs?
Oh, yes. So, I wrote a little Ansible script to pull the logs. It's not a super.
And also, the Prometheus stats in some kind of JSON or.
Oh, so if you want stats from the dashboard specifically, there's a pretty easy way to grab them. You can literally just export CSV.
Oh, but that's a manual. I'm thinking more of
an automated one. Yeah, so if you want to automate it, then we're going to have to do something with like InfluxDB or SignalFX or something where you. Sure, so SignalFX has an API. Right, Greg?
Sorry, I think we can make a curl call that calls into the API and do the same export.
Yeah,
We can use that automatically.
exactly. And I mean, like this in this setup over here with InfluxDB Grafana instance, InfluxDB has a whole API exposed, so you could extract it out of there. But then again, we have to know which parameters you want extracted. Because otherwise, then Anka, you might as well, if you want all the data extracted, then InfluxDB has a command line interface that's kind of SQL-like that you can use to interact with the metrics, and you can pull out specific transformations of the metrics that you want. So it depends on what you want to do with it. So like if you've got a dashboard,
final goal should be to have a bunch of scripts, the ability to run them on every release, and do everything automated, right? And
definitely, yeah, that's definitely what we want to work towards. But I just don't know what that looks like.
And whoever builds the actual scripts on top of this infrastructure will have to figure out, you know, which stats and which how do you prove you know, an image or a network behaved or not behaved depending on what you're testing, right? But
yeah. Yes, that's actually what the feedback that I was talking about earlier that we need is which specific metrics do we need? Because it's easy to get the metrics. We need to know like what metrics to get and how to display them, and then it's easy.
Yeah, well, I think for me it's the other way. Like once we have this kind of in place, the infrastructure in place, oh, we will come up with a lot of metrics. Don't worry about that. We'll find what we need for the tests.
So if you look at this, and if you look at, I don't know, Anka, if you're taking a look at Signal FX, if you've logged in there and checked out what it can do.
But yeah, I think I've seen right now the pull down. I mean, I think it's easy to come up with the metrics once we know, you know, we have the ability to put this in and we start experimenting. For example, for fasting, I can think of a few scenarios that I want to test, and you know, we need to enhance the Prometheus stats. We need to add more debuggability there. But once we can run and collect all the information, and it's going to be amazing. I don't know.
So I mean, as it is, all the information is collected. It's all stored in the Influx. In this example, it's stored in InfluxDB running on this little monitoring server. But once we integrate it with SignalFX, then it's all going to be stored in SignalFX. And then you're free to come up with whichever dashboards and metric analyses that you want. So what I'm saying is that all the data is already collected. So with these particular scripts and things. So then it's just a matter of actually logging in, creating a dashboard, figuring out which metrics you want to display.
Can I just say a few things?
Yeah.
So for local testing, I think we can just use localnet,
sure,
which is like a Docker compose.
Yeah, I'm familiar with localnet.
I'm not really convinced that we need a full-blown 100 nodes network just to test a pull request, whatever. Like whenever,
not at all.
Whenever a pull request like degrades performance or something, like slows down Tendermint.
I agree completely.
But for production, for people who don't know, we have some Kubernetes scripts actually. I wrote them like 2 years ago. And you can find them in a tools/mintnet Kubernetes.
Cool.
And they work for me. And right now they're probably outdated a little bit, but they work. There is a learning curve to Kubernetes, but once you know what you're doing, it's very easy. It's like much easier than Terraform and Ansible.
Yeah.
for example, I was able to spin a network with just one command, basically.
Yeah,
and
exactly.
So we can, we can certainly continue with the Terraform and Ansible. It seems like super promising. But I also encourage people who are watching and maybe some of you who are interested to check out Kubernetes.
Definitely. No, I agree. I think that, and our aim over here was never to come up with something that gets executed on every pull request. I think that definitely the local net approach makes sense to execute on every on PR level. But like at release time, it kind of makes sense to run some kind of set of performance tests, especially like a geographically dispersed set of performance tests, and to be able to meaningfully compare from release to release, like, you know, are we progressing in some way, or are we regressing in some way? And I definitely think that Kubernetes could help a lot, but like you say, the learning curve with Kubernetes is pretty steep. I can already think of a way to come up with a Helm chart, for example, to do all of this in a single command with Helm on a Kubernetes network. But again, then it's a matter of like, how do we facilitate situations where you have complex multi-step sets of interactions where you run a network for a while. Let's say you actually want to run a network for like a week first, and you want to bombard it with transactions for a week. This is not like a release-based test. This is something that, say now, for our own internal development purposes, we want to execute. Run like a relatively long-running test network, and then you want to start fiddling with the network, like adding additional validators, removing validators. You want to break particular nodes. You want to break the network connectivity between particular nodes. And it is all possible with Kubernetes and with Helm charts. But then you also have to learn about how Kubernetes handles the networking, for example. If you want to fake network connection breaks between Kubernetes or between Tendermint nodes, that over there isn't so straightforward. So, and that's a whole other kind of learning curve, where if you're used to VMs and doing things on a VM level, then the Ansible Terraform way is probably, so right now this is definitely deficient. This is definitely not the end state of what we're trying to work towards. But the VM-based approach will require some kind of Terraform Ansible approach. And then if we go Kubernetes, then we have to kind of invest in that learning curve on all levels. Does that make sense?
Yeah, I would just add that so this is interesting for performance reasons, but also for correctness, because we are with a local setup, we are probably bounded with what we can test there, unless we have more sophisticated network simulator in place, so that we can really kind of simulate the WAN behavior and lossy links and whatever. So as part of the release, eventually we want not just to check whether we have performance degradation, but also whether we introduce some bugs in a system, which with our local integration testing, unit testing and integration testing, we might not be able to catch. And so this seems like, I think, at least it could be used also in that context. Whether it's the most efficient way to do it, so this is like it's a different story. But at least we can use it for that purpose. Now, if we can kind of build something locally where we can configure things and then have some kind of simulation-based network, and have evidence that this really corresponds to the wide area network, then this can be probably much faster and cheaper. But I think in any case, we probably won't have such kind of full-blown setup, at least to be used as a checking stage for our simulator-based local setup.
Yeah. Cool. So, any other questions for now? Is that it for today?
I think that was pretty great. We covered a lot. I at least have to jump off. So
cool.
Thanks a lot, Thane, for preparing all that and for the presentation.
Cool.
I guess we'll follow up online.
Awesome.
Great. Thanks, everyone.
Yeah, thanks everyone.
Thanks, everyone. See you guys.
Have a good day.
Thank you. Goodbye.